quality control, and today lecture will be about part 2 of chapter 5. We will start where we stopped last time. We completed the, yes, we will start with continuing the points where the out of control and regular variation in the control charts could happen. I told you in the first part that I'm going to provide you with more examples about the points that stated in the previous slides. Here are the example of the first 4 rules for the control charts. And here, this is the typical out of control when you have a point out of zone A or out of control. Here, when you have 2 out of 3 points, consecutive points are falling on zone A or beyond, that's mean 3 points, 1, 2, 3, fall in zone A or beyond, that's mean it is close to the control limits and it is about to have a control out of control event happen. So this is an event need to your attention to focus on the process. Here, 4 out of 5 consecutive points fall in zone B or beyond. That's mean you have to count points. These are 5 points, and 4 of them fall in zone B or beyond. This is 1 in zone B, and this is in zone C, then other 2 in zone B, and then in zone A again. The same here for this one. We have 4 points, 1, 2, 3, 4 in zone B, and then 1. The last one was in zone C, and also 9 consecutive points on the same side of the center line. So there is no points below, or all the 9 points will be below, and there is no points above the center line. Here is more examples and figures, continuing with the events that need your attention. If you have it in monitoring your process, you can follow these figures, and this is just a translation on whatever here stated in the remarks about the control charts. It is illustrated here, so it will help you to visualize the problem. A question like this could be having an example of a control chart with an event and ask you to identify what type of event is here stated in the illustrated picture. So a picture could show you one of those examples here or in the previous, and ask you to identify what is the violation here, or what is the points needed to pay attention on. So you have to state the rule that is match the figure. So I will upload this version on the Edmodo, since it was not in the original from the book. This is an extra, or also you can screenshot this figure. Then the next tool we have under the SPC is the Pareto Chart. The Pareto Chart is where we have it on chapter 1, I believe, and we have illustrated how we do it on the mini tab. The Pareto helps you to focus on the major causes of the defects. For example, here, the incorrect dimensions and part damaged comes at the beginning. So those two needed for your attention more than the remaining, because if you resolve those two, you will resolve 80% of the defects. And the rule says 80-20 or 20-80. If you consider the 80 defects happen from 20% of the type of defects, that is the rule of Pareto. It is similar to the histogram, but the difference is organized based on the number of defects appear under each category, and then helps the management to focus on the most causes so they can resolve the most damage. The defect concentration diagram, this is similar like when you go and rent a car. If you have this experience before, they give you the diagram of the car, and the person from the car rental shop comes around the car with you and mark where is the defect, like scratches, bends on the car before you receive it and after you return the car to the car dealership. So basically you draw the product, like here we have a refrigerator on the left side, and it shows the defects where it is placed on the sides or in the back or in the front or bottom or the top, and you identify the type of the defect. For example, here on the right side, they identified A as a scratch, B as a neck, C as a scuff, D moon. This is regarding to the tank here example, but on any product, the identification or the defects code, it will be vary or it will be different. Implementing SPC in quality improvement, to have it succeeded, the management leadership, you need their collaboration. Otherwise, the quality or the SPC will not succeed, because after you identify the root causes, after you identify the problems, then it is going to be required from you that to resolve it and needs authority to resolve it. So if the management leadership didn't collaborate with you, then that will not help in improving the process. A team approach focusing on project-oriented application. So usually it is not one person. It needs teamwork to be done. Right, there is a specialist in statistics or industrial engineering. He can coach the team, but also it needs collaboration from all the other team members to improve. And it is project focused. That means the scope is very narrowed, and this is the unique about the SPC compared to quality management's philosophy that is organization oriented. Here it is a project fixing problem by problem in the organization. Education of employees at all levels. You have to educate the employees about the implementation of the solving the problem, so they collaborate with you and help you in solving that, because you will need their help. You cannot just fix the process without educating your employees and showing why you are doing these changes. Emphasize on reducing variability, and this is the good thing to improve the quality, because the variation it will cause defects, and also it will cause losing customer satisfaction. If you have experienced with the services, for example, if you have been experienced with bank or telecommunication company, you as a user, if you went to the bank and the long time was waiting, the staff was not helpful for conducting the services, then it is hard really to for you maybe to have return to that place again, maybe unless you have to do that or you are obligated to do it. But in this case, if you have one time is a good experience, and then you have one time other experience was bad, or one person has a good experience and the other has bad, this is variability. It will not stabilize the satisfaction of your consumers or customers. So that's why the SPC tried to reduce the variability to improve also not only the quality of the product, but also the user's satisfaction, whether it's a production or service. Measuring success in quantitative, and this is the good thing, the quantitative different than the qualitative. Quantitative numeric, you can analyze it, you can get numbers out of it, you can transfer it to cash money out of that. The qualitative, it may mislead in terms of the direction for improvement. A mechanism for communicating successful results throughout the organization. You have a communication tools or communication templates for your team and for your project, like what we did see in the Six Sigma project. One example of the SPC is very famous, and we have it as a separate course, is the design of experiment to optimize a process. For example, here to minimize the plating defects. So to optimize the plates, you can use the process variables, like here we have for the plates, and then you apply design of experiment to implement it for optimizing the production or even the service. The non-manufacturing application often don't differ substantially from industrial applications, but sometimes requires ingenuity. What does it mean? The service is not different than production. Also, it needs your attention. It needs your focus. Even though the quality and the concept of quality control and improvement was first applied in production or in manufacturing, however, the changes then happen and success in the production is being conveyed to services. And in the service industry, it showed how also it is similar to the production. That's why we hear also these names, like they call it education industry, healthcare industry. They become also industry. And that is the reason why you as industrial engineer, you can fit in both manufacturing organization or industry or service industry. Because now whatever rules applied in the production, it is being conveyed to the service sectors with the changes needed to adopt it in the service. And now we see the machine learning and automation that is also to help the service industry to be improved and more reliable and reduce variability comparing and similar to the production industry. Service industries are very wide examples, like we have education, we have healthcare, we have banking. All those are service industry. So that's why it is needed, because usually you don't have natural measurement system. Maybe in the production, you have it in the production line, but the service, you need it sometimes to be implemented or designed by you as a management, like what we have in some companies. When you call them, they tell you that the code is being monitored and recorded for quality purposes. This is one of the tools to measure the system. The observation or the observability of the process may be fairly low. That's mean, as we said, you cannot observe the service because sometimes it is happening between one-to-one. So you are in a big company for the service like telecommunication. You have many branches. You cannot monitor all the processes. If we consider also like those phone application, like those food delivery, Hunger Station or Kareem or whatever application, this is a service application or service industry, but it is hard to observe the process. That's why the tools needed sometimes need some kind of manual input from the user to monitor how was the process, or sometimes they use tracking to track the driver and make sure he was following the right route for your direction. People also are usually involved in the transaction, and this is the reason why the variability is higher than the manufacturing industry or the production industry. In the production industry, machines variability, even if it is there, it is determined and it is clear. But in the service industry, it is really hard to track it. And also it is obvious to see variability because or due to the human nature. Human, they can be affected by emotion, by fatigue of working long times. Their emotion can make their judgment or make their job day by day or hour by hour different. So that's why the variability where the human, you see them, it is higher, and that's why it's in the service, you see them higher than the production. And this is one of the reasons why now you see many of the automation and intelligence, artificial intelligence applied in service to reduce the human errors. Doesn't mean that human is not needed, but for the jobs or for the task needs consistency. Maybe that is the reason why the machines are here. It is better. A human, they can do management, can do strategic planning, can do monitoring, can do also resolving. But in terms of the routine jobs or routine tasks that has steps or can be converted to algorithms, so it can be automated using machines. Flow charts, operation process chart, value stream mapping, also useful tools under the SPC. We will go over them quickly in the next slides. And it is very important to identify the value added and the non-value added in your process. Transaction, someone is asking what is transaction? Transaction mean عملية. Service transaction, عملية خدمة. When you go to the ATM and you ask for withdraw money or سحب مبلغ, this is a transaction. You go to do withdraw and pay bills, this is two transactions. So each one considered to be a transaction in the service. You have to identify the value added and the non-value added activity in order to improve the service process. These are very good ways to eliminate the non-value added activities. My capstone team project, they are working on reducing the non-value added activities in one of the mail office in Medina. They have used most of those tools here, or most of these steps, rearrange the sequence of work steps. That's mean the work order. If you remember how you used to issue your driver license or your passport long time ago, maybe 20 years ago. I don't know if you had driver license that time, but if you can, maybe you can remember or you ask your parents, the process was very hectic and too many steps needed. So now the sequence is different and it is mostly automated. Rearrange the physical location of the operator. Sometimes there is a waste or non-added value activities of motion or traveling distance in the organization. So it is hard for the, or it is going to cause sometimes part of the variability in the process. Working method, changing the type of equipment used in the process. It could be old or it could be slow. Redesign forms and documents for more efficient use. Sometimes documents and forms need too much steps or too many steps to be processed. So it would be better to redesign it to be it convenient and to be cutting non-value added activities. Improve operator training. If there is no training for operators, you have to also, if you have and it needs improvement, because the training, this is one of the things that in service industry they don't really invest on, and it causes many defects in the transactions. If you go to shops where they hire just people, especially with the Saudization now, they are forced to hire, but they don't invest on training. So you may experience with dealing with non-trained or untrained employee, and maybe you had this before, and it caused disaster for you when you deal with some such like that. Sometimes it causes to even wrong transactions conducted. Improve supervision needed. Identify more clearly the function of the process to all employees. They have to be educated about all the functions, why they are doing it. They have to be involved in the organization, not just doing their task. To try eliminate unnecessary step. Again, it could be work or methods. Try to consolidate process steps, optimize it, reduce it, or you can also combine it if it can be. Before we go with the operation process chart, this is the symbols needed to be recalled, maybe in exam, so you have to recall them and know what is the difference between them. This is for operation, this is for inspection, this is movement or transportation, delay, storage, and those are implemented here in one example. You can see them in example like here, operation. We have it here, and the storage, we have it here, and then we have the movement and transportation like here. So just to know what is the identification for those symbols, this is to identify the process flow. Similar, or on the other hand, we can say it is similar in terms of the visual appearance, but it is different in the concept, something called value stream mapping. This is a very useful tool, and sometimes people think it is close or it is similar or it is the process flow. It is different than the process flow. Here, this is a process flow, so all the symbols here are identifying the process. In here, it is for the product. So all the steps here, not for the process or for the human or for the system, it is for the product. So this is what you need to identify, read or understand. The value stream map presents the picture of the value stream from the product or viewpoint. How the product is traveling, how the product is traveling, not the process, how it is conducted. Like sometimes you demonstrate here human circle shape. It is, but is the difference between the circle shape and the value stream mapping is the time it is calculated in the value stream mapping for the processing time, inventory time, leading time. The cycle, it doesn't do that. Here, those times that need to be calculated, and it helps you also to convey that or convert it to a simulation arena, so you can simulate the process. I ask you to read those parameters from lead time to work in process and information flows, so you can understand what do we mean by calculating the time of the product when it is flow in the process. So let's start with reading one by one. I will give you a minute or two to go over those before I explain them. Lead time is the time it takes for the unit to move through the entire system. So this is what usually an important metric to see the product when it starts to end, how much the total time needed. The processing time is the for entering the process until it leaves the process, but it could be different processes in the map. The cycle time, this is the rate calculated by dividing the process time by the number of people or machine doing this. So this helps you to identify the right resources needed for the process. And the setup time, it shares or it shows the activities like machine loading and unloading by whether it is machine or operators. In other words, all activities that take place between completing a good product until sharing or starting to work in the next unit. So if you can imagine the cooking, preparing for the cooking that needs bringing vegetables or unloading from the refrigerator and having all the ingredients ready. So this is one of the examples for the setup time. Available time, this is the time each day for the value stream can operate if there is product to work on. If there is a product to work on, that's considered to be available time. If it is not, that's mean that the product is not working or the process is not working. The uptime is the percent of time process usually operates as compared to the available time or planned operating time. That's mean it is comparing also the available time to the actual operating. Sometimes you have a planning for availability time, but then you have uptime that is more than what you planned. For example, like in season, when you are planning and there is extra demand for a product, then you have uptime calculated, or sometimes you have some delays, so it will cause for you to have an extra time for working, so that is considered to be the uptime. The pack size, the quantity of products required by the customers for shipment, that's for the needed to be shipped to the customers. The batch time is the one for the quantity of the products worked and moved on time. So you are having an order from Amazon, for example, or any online shop. How many products you have ordered, when they start leaving the source or the store online, that's considered, or how many of them they started to leave the store and come to you, that's considered to be the batch size. The batch size is what you order, the batch size is what left from there. The queue or queuing time, this is a whole concept, and there is a whole study under only just the queuing. If, for example, if you remember when we had the pandemic at the beginning, when even the shipments used to be delayed worldwide due to the pandemic, so the queue time used to be very high for the products to be shipped over the world. The work in process product that is being processed but is not yet complete. So you calculate how long it is being processed but is still not completed for any reason. That will help you maybe to identify what is the causes that the products stayed in the system but is not completed. This could be happened and sometimes could not happen. But also this can be identified in different steps in the map. So it shows that how is the product is moving between a step to another. information flows. This is just to show each process what it will have next. So it is more of steps or forecast. The process cycle efficiency, it is calculated here based on the value added time and the process cycle time. I believe this is in the operation planning control. It is being covered. If not, we will not cover it here, but if not, then we can give more example as an extra to show you how you calculate the processing or the process cycle efficiency out of the scope of this chapter, but we can cover it if you have not covered it yet over there in the operation control. This is an example of the value stream map, how it calculates the cycle time, the processing time, available time for the product, starting from the order of the customer and to the supplier. Then when it is processed, all the steps for processing until it is goes to the customer again, and then it shows you here at the end, it is cumulative time here. It shows you at the end the total leading time and total processing time. So from these metrics, you can, or from these quantitative numbers, you can analyze the process more and identify your average processing and your average leading time for number of shipments, and so also you can identify the how you can improve it and how you can reduce those times, because if you can improve in reducing them, that's mean more products will be processed to the customers on time, and also you can accomplish many orders and improve your sales. In the business, the transactional service, we were talking about how in the service, the quality improvement and the SPC can be implemented there. This is, I would say, it is for your own reading. It is more of generic information, like the quality improvement tools can be used, including the design of experiment. Basically, design of experiment, as all the other SPC tools, as it was applied in the production or the manufacturing, it could be implemented in the service, especially with these days now of the automation. So more even tools can be implemented in the service. This is all for this chapter 5. This is where we stop, and we will maybe have more information. I can put it as an extra after we complete the core information of this course to help you in real life application. But this is as far as the chapter 5 needed, and we will continue with the control charts for continuous, which is chapter 6, and attribute for chapter 7 in the next lectures. Now it is the time for answering the questions. So we'll stop the